Good morning. All right, let's begin. In Tuesday, we're going to be back in the classroom again, upstairs. So I'll see you then for that. And also on Tuesday, your homework assignment 12 is due. So we have a quiz on Thursday, which means that on Thursday we'll be back in here in the computer lab so that if needed, you can have access to Excel for the quiz. Any questions related to the announcements? All right. So you probably have already noticed that I posted the scores on iLearn for the reports. And if you didn't already pick up your report, you can get that after class. I have numbered feedback. And I did that just to save my hand some cramping, because sometimes I'll see the same issue in multiple papers. Rather than write it every time I see it, I just made up a key of issues. Now, I would only put maybe the main issues that affected each paper. So, for example, item 7 says there appears to be a calculation error in the spreadsheet. It's possible that you have a calculation error that I didn't notice. Just because you don't see the number 7 on there doesn't mean that your spreadsheet's absolutely perfect. It means that I just didn't notice the mistake. In other cases, it maybe was a minor issue, and so I didn't bother drawing attention to it. But if you're wondering in general what some of the issues, strengths, and weaknesses were with your report, I hope that this feedback form will give you the details. Please feel free to stop by my office if you have specific questions about your report. In general, I thought that there was a lot of really good work that had been done. Reasonable assumptions, good estimates. In most cases, the time value calculations had been done appropriately. There were some cases where people hadn't corrected for costs in the future being different than what things cost nowadays. But in general, I was pleased and impressed with the reports, so nice job on that. Today we're going to be continuing in Chapter 13 and doing something known as payback analysis. And so the in-class exercise today deals with the idea of using payback time to compare alternatives together. So before we get into that in-class exercise, let's go over a little bit of terminology here. The first thing is we can calculate based on the amount that something costs and how much revenue we can expect from it, the number of years required to pay off the initial investment. And so take, for instance, a purchase of a piece of equipment, and if you know what the present cost of that equipment is, and you know an annual value of net revenue, meaning the difference in the operating costs of the item and the amount of revenue that it's going to generate, then you can find the ratio of P to A, and then compare that ratio to the tables on the back of in the back of the book, and then find out where's a crossover point from profitability to unprofitability. So that's what payback period is it's the number of years you need to receive the revenue in order to pay off the initial cost. Now, simple payback is pretty uncommon. It's assuming that there's no time value of money that needs to be accounted for. So 0% interest. In other words, if you bought an item for $5,000 and you're expecting a revenue of $500 per year, then the simple payback would be just 10 years. But what the simple payback doesn't take into account is that $500 in the future is worth less than money now. So simple payback is pretty uncommon. Discounted payback, on the other hand, is when we take those future values that we expect to receive and we discount them at a known interest rate I. And it's the discounted payback amounts that we can use when we're creating the unrecovered cash flow balance. And the idea of unrecovered cash flow isn't new. It's something we've talked about in previous classes. It's when you think about it in terms of how much money you gave up to begin an investment or to purchase an alternative at the beginning of its useful life, and then the amount that you have not yet recovered of that initial investment is the unrecovered investment balance. And so to calculate it, you need to begin by discounting the payments you're going to receive to the present value, and then year by year combining the previous unrecovered investment balance with the amount of revenue that you received for that year. So this payback analysis that we're going to do today is only a screening tool. What we'll do is we'll look at two alternatives. One option can be paid off quickly, and the other option takes a greater number of years to pay off. The thing that we should compare those times to is how long the equipment will last. Because think of it this way. If you took a loan for a car and you have to pay back the loan over 5 years, okay, but what if the car only lasts for 3 years? Then in the last 2 years of the loan, you're paying off a car that you don't own anymore. And that would seem pretty unfair, right? If you're still paying for something that you don't use anymore. And so the screening logic is that if the useful life of the equipment is less than the payback period, then you should reject the alternative. But if the useful life is greater than the payback period, then it can be a good option. It doesn't mean that it's the best option, though. It's just an initial screening tool, a reject or accept based on how long the equipment is expected to last versus how long it takes to receive the payback. Can you say that again? You're talking about the car? I still don't understand the setup. So when I was talking earlier, I was saying you compare the... What? No, we're not how long you own it, how long until it wears out is what I was saying. I was saying after 3 years, the machinery is worn and it has no value. And so I assume that you stop owning it, but you didn't receive any salvage value when you disposed of it in the example that I was suggesting. It was just a comparison of the useful life of the equipment to how long it takes to pay it off. Okay, so that's what I mean by screening, is comparing the life of the equipment to how long it takes to pay it off. Now, comparison you have to be really careful with. You remember that there have been cases in the past where you shouldn't compare one thing to another and make a decision based on it. That's one of those hidden landmines. For example, comparing IRR. You're not supposed to make decisions by comparing IRRs. Remember, because it could be that the thing with the lower IRR is actually the better alternative. So this is another case of one of those things that you might be tempted to say, always choose the item that can be paid off most quickly. But that's not necessarily true. You can only compare the alternatives directly if they have the same useful life and generate the same revenue. And if that's the case, then you can select the alternative that's paid off the most quickly. But here's the warning again. The problem with payback analysis is it doesn't take into account what happens after the item is paid off. It's only telling you how many years it takes to break even. And so it may be that one of the equipment items continues to generate revenue for a long time after it's paid off. Even if it took a little bit longer to pay off, it may have a longer useful life. It may be generating more money in those later years. And so for cases like that, what you want to do for the ultimate decision making, you can always trust present worth analysis. And we're going to see that in today's in-class exercise, a comparison that highlights this warning. One of our options today will be paid off more quickly, and so you'd maybe think that's better. But then when we look at the present worth of each alternative, it's actually the one that was paid off more slowly that ultimately generates a higher net present value. So here are some notes that I'd like to put in your mind. Today's in-class exercise has the table lookup factors on the back. So the first part of today's in-class exercise, you're going to compare a P to A ratio that you calculate based on numbers that I give you to the values on the table. And you'll look for a crossover point. You'll try and find out the value you calculated, where does it fit on the table, which row. And the row that you find on the table corresponds to how many years it takes until the present and annual amounts are in balance. Okay, the second bullet point, I'm drawing your memory to the idea of unrecovered investment and balance and how that's calculated. What you're doing is you're taking the inflows in the future, converting it to a present value, and then accumulating those amounts over time, starting with the initial cost. And so on the paper, I've mentioned the column titles that you'll need to do that. The column titles, what year it is, the amount of the cash flow, the present value of the amount, and then finally the unrecovered investment balance. And now, this third bullet point, I'm introducing a new function to you today. We've done PV, we've done FV, we've done PMT function. So there's a new function here that's NPER. And if you remember the abbreviations that are used when we do cash flow functions in Excel, NPER is the function that it uses for the number of years. And so this function will tell you the number of years to get the present value into balance with the payment. So how many payments does it take to cover the present value at a certain rate? So it's going to essentially return to you the payback period. So with those reminders in mind, let me give you the paper, and you can go ahead and begin on the in-class exercise. Did everyone get the hand calculations part where you have the ratio P divided by A, and then you won't find exactly this number. If we go to the table, you won't find exactly 8.36. Oh, I didn't copy the table. All right. It's between 14 and 15, and you choose 15. Because the payments come once per year, so after 14 years it's not paid off yet, but after 15 it is. Okay, let's just talk about part one so that we're all on the same page before moving on to part two. Are there any questions from part one about what we did, first of all, with the ratios, the manual approach? What we were doing was the P divided by A, so 92,000 divided by 11,000, and you got some ratio, and then you went to the table and looked on the P/A column, trying to find out where's the crossover point. And then that tells you what year it goes from negative amount to positive amount. And this illustrates that. So what this unrecovered investment balance column is showing is in year 0, only you have paid. You received no revenue yet. At the end of year 1, you got $11,000, but that $11,000 is only worth $10,185 because we're taking everything back to year 0 because you want it to have the same comparison as the amount that you paid, and you paid the amount at year 0. That's why you need to take all of these revenues and discount them to the present, is because it was at the present that you outlaid your initial investment. So this is showing that at year 14 you're getting close to a 0 unrecovered investment balance, but you're not there yet. So it's after 15 years that it's finally paid off. So if you do the NPER function, it tells you the crossover point's at 14.37 years. But I mean, having a decimal is sort of useless because these payments are made in discrete year increments. So you have a payment in year 14, and it's not paid off yet, and then in year 15 it is paid off. Yep, let me show you the formula for that. So what we do is for the first year, it's just the present amount because it's already in year 0. And then for the next year, it's the previous, so the one above it, so the previous year's unrecovered investment balance plus the amount that you've received during that year. And so what the next row after that is going to look at the one above it, adding to the one to the left. And so each one of these is just a cascade of the previous value plus the revenue from that year. And then we see the final crossover point happens after 15 years. All right, so let me tell you about part 2. In part 2, we're comparing two machines. You'll notice they have different useful lives. So we have to be careful about using the payback time. Remember, the payback time is just a screening tool. So you're supposed to use the payback time to give you an idea should the item be rejected. And in what case should you reject an item based on payback time analysis? When should you reject an item in payback analysis? If the payback is greater than the useful life. If you're still paying for the item even after it's finished and gone, then it's not going to be a good economic choice because you're not receiving more revenue after it's gone. Okay, so the issue with these two machines is the first thing, calculate the payback time only using 7 years for machine X and using 14 years for machine Y. So don't repeat machine X for part A. But then for part B, where you're doing the present worth analysis, then you should use the repeatability assumption for comparing the two alternatives, because to compare two alternatives using the present worth method, by definition, we have to repeat the cash flow diagram for option X, for machine X, whatever that is. But don't repeat it when you're calculating the payback time. What? No, there's not. No. If you wait just a minute, I'll have it up on the screen. Okay, for part two, I hope what you're finding is that the first option, option X, if we take a look at the unrecovered investment balance, now we have to use that. We can't do the NPER for alternative Y anyway because the amounts are changing. We could use NPER to find the break-even for alternative X, but since we have to do the unrecovered investment balance method for part Y, for item Y, I just did it both ways. So if we look at this, it takes 6 years before option X is paid off. That's when it goes from negative amounts, meaning you haven't yet earned back any profit, and now you have a positive amount, which means you're finally keeping a profit. Compared to alternative Y, it takes 2 years longer to pay off the item. And so if we only do the comparison based on break-even, it would look like alternative X is better because it takes fewer years to pay the item off. But what that ignores is the fact that item Y lasts longer. So item X has to be purchased again. And let's see, did I put the amount in the right? No, looks like I put it in the wrong year. I need to put it in year 7, not in year 8. Let's see. Here it is, so minus. All right. Yeah. So we have to buy the item again at the year 7 to go through a second cycle. If we're comparing apples to apples and 14 years of service, then it turns out alternative Y is better because it has the higher present worth. Even though it takes longer to pay off, you're still getting a better value with option Y. Any questions about that?